Welcome back. It's now time to look at turning our sequences into recurrence relations. Right? If you recall, there are two types of sequences. There are arithmetic and there are geometric. And what we're going to do at the end is show you how to develop them and make note of them on your calculators. Now we use a scientific or a CAS calculator here, but the class pads will do the same thing, just with a slightly different process. Ready to go? Let's get arithmetic out of the way. Okay, the basics. Now, this is the hard bit that confuses people. This is a recurrence relation. What does it mean? It's just gobbledygook. But the best thing you can do is put it into English. Put each of these bits into English, and it all starts to make sense. Okay? Let's go through it. This A value first. A is the start value of your sequence, okay, the very first number. This D is the common difference. Now, this is for an arithmetic sequence. Remember, we had arithmetic as adding. This is the plus, a common difference. Geometric, which we'll go into a little bit later, has a common ratio where we multiply. Now, these are the bits that you need to remember. First up, Tn. Let's bring that across. What does Tn mean? Now, that is simply the value of the current term in your sequence. Okay, what the number you are actually on. This one, Tn plus 1. If Tn is the current term, Tn plus 1 is going to be the next term in your sequence, the value of the next term. T0, now if A is the start value, T0 is just the way we say the value of the initial term of your sequence. Okay, so we've got the initial term, we've got the current term, we've got the next term. Now there is one other one which you might come across. I'll give it to you now, but if you put it in English, it makes sense. It's Tn minus 1. Tn minus 1. If that's current, that's next. This would be previous, the value of the previous term, the one before. You get that more in year 12. Just be aware of it though. Now, here's the bit that makes sense. Let's put it into English. T0 is the value of the initial term. So in this case, the first term or the initial term is A, whatever the A is. It could be 0, it could be 5, it could be whatever the first number of the sequence is. Then this bit, Tn plus 1 is the value of the next term is equal to the current term there, current term, plus a common difference, as it says. Okay? If you're not sure, put it in English. Say it in English. Don't just say T0 equals A, Tn plus 1 equals Tn plus D. Well, it's just variables. Put it in English. The first term is A. The next term is equal to the current term plus the common difference. Ready to have a look at some arithmetic sequences? Let's apply it a little bit. Okay. Now, remember an arithmetic sequence has a common difference. So does the arithmetic recurrence relation. What it looks like is what we've just seen. The T0, the initial value is A, whatever it is. The next value equals the current value plus the common difference. An example, 2, 7, 12, 17, 22, 27. There are some steps, and it applies to both recurrence relations, arithmetic and geometric. The first step is find the initial value. Makes sense? That's at the front. You have to write an initial value. What's our initial value here? 2. So just make a note. The initial value, T0 equals 2. You can just write T0 equals 2. That's fine. I've just written the whole thing to make sense of it. The second step, decide if the sequence has a common difference or a common ratio. Now that means, is it arithmetic or geometric? Now let's have a look at this one. 2 to 7 is plus 5. 7 to 12 is plus 5. That's plus 5, and so on. So it's plus 5. There is a common difference. So write it. The common difference with D equals 5. This is the most important step. This is where I see so many people stuff things up and lose what are realistically easy marks in Year 12 on exams. Write the blank recurrence relation. Okay? The way people stuff it up is they get this part, the Tn plus 1, the next value equals the current value plus the difference, and they forget to do this. You have to have both parts. Okay? You have to have both parts to this recurrence relation. Once you've written the blank, it's easy. All you're doing is substituting your T0 and your D into it. So A equals the T0 is 2. And the Tn plus 1 equals the common difference, sorry, the current value plus the common difference, which is D equals 5. Done. Please write the blank. Yes, I know it's an extra line in your book, but please write the blank. Let's have a look at another one. 12, same steps. Initial value is 12. So T0 is 12. Is there a common difference or common? How do we get from 12 to 9? Subtract 3. Is it subtracting 3? 9 minus 3, minus 3 minus... Yeah, it is. But have a look at this. Remember, it's plus a positive or negative number. So instead of plus 3, we need to write a plus. Instead of negative 3, sorry, we need to write plus negative 3. So a common difference is negative 3. Third step, write the blank recurrence relation and substitute our A value in, which is 12, and substitute our D value in, which is negative 3. Done. Nice and easy. All right. Go get some arithmetic recurrence relation practice in, and I'll see you back here shortly for some geometric stuff. Unless, of course, you want to have a look at geometric now, in which case, here it is. All right, geometric recurrence relations. Now, remember that arithmetic, add, geometric has a common ratio which is multiplied by consecutive to get to consecutive terms. So it looks slightly different. The T0 equals A, then it's the next term equals the common ratio times the current term. Same steps apply. Exactly the same. Let's have a look. 2, 6, 18. How do we get from 2 to 6? Well, sorry, before that, the first term. I even got myself out of order. Find the initial term, which is 2. Next thing we do is it arithmetic or geometric? Yes, times 3. 6 times 3 is 18, times 3 is 54. So yes, the common ratio is 3. Third step, write the blank. And fourth step, substitute our 2 and our 3 in. So T0 equals 2, Tn plus 1 equals 3 times Tn. Now, remember in algebra, when you have a constant multiplied by a variable, like 3 times A, you don't have to write 3 times A, you just write 3A. Same thing applies here. So instead of 3 times Tn, we have 3Tn. Done. Initial term is 2. The next term equals 3 times the current term. Now what do we do with this one? 60, 30, we can minus 30. Sorry, let's get our initial term first. I've done it again. Initial term first is 60. There we go. Is it arithmetic or geometric? Let's see, minus 30 minus 30 minus 30 is not 15. So we could divide by 2. 60 divided by 2 is 30, divided by 2 is 15, divided by 2 is 7.5. But remember, it's multiplied by. So instead of divide by 2, we have to write it as times a half. 60 times a half is 30, times a half is 15, and so on. So our common ratio is 1/2. Third step, write the blank recurrence relation. T0 equals A, Tn plus 1 equals R times Tn. The initial term is 60. T0 is 60. The next term is equal to 1/2 times the current term. Done. Same process, just have the two hardest parts. deciding whether it's arithmetic or geometric, and then writing the blank recurrence relation. Otherwise, it's dead straightforward. Now, the fun part, developing them on your calculator. All right, let's have a look at this one here. T0, is that arithmetic or geometric? Let's have a look here, +9. So this is an arithmetic sequence because the +9, it's got a common difference. So our initial value is 4. Let's have a look. We'll do scientific first, since most of us have scientific calculators. This is just the Casio one. There's Sharps, there's TI Inspires, there's all sorts of other ones. And they all work exactly the same. On your scientific calculator, ignore what's in here. We're going to wipe that out in a minute if you follow these steps. So the downside of doing it on your scientific calculator is you have to write each value down every time you press 0. You haven't got a memory of it. Okay, so you'll see what I mean in a second. So the steps are, our initial value is 4. So we press 4, then we press equals. So 4, and that goes like that, and then equals, it puts the 4 down here. You have to write the 4 down as you're doing it. Next step, our common difference is +9. So we're going to press +9 and then hit equals again. So +9 and then hit equals. And you see what happens here. Answer +9 equals 13. You have to write the 13 down. From then on, it's really easy. You just press equals. Press the equals, and it changes to 22. Write it down. Press the equals again. It changes to 31. And so on. And keep writing down your numbers. Okay? So you just have to keep pressing equals after that. So you initialize it with the 4. You go +9. And after that, it's equals, equals, equals. But write them down. What do you do on the CAS? Well, this is a little bit easier. You have to go to your scratch pad, your calculator. And the difference is, works exactly the same. Initialize it with the 4, then go +9, but not equals, you press enter. So let's have a look. Press 4, then enter. So let's have a look. 4, then it comes up there, you press enter, and it goes like that and shades the bar. There's our initial number, initialized. From there, again, press +9, then enter. So, plus and 9, and it goes answer +9, and you press the enter button, and it comes up 13 there. What's the advantage already? You can see. It tells you what the sequence is. It keeps it in memory, doesn't it? Then we just press enter again. So I press enter again, and the next line pops up, and enter again. And the next line pops up, 31, and so on. You don't have to write it down each time. You only have to write it down at the end. All right? Any questions with that? Ask your teacher, because I can't answer over YouTube. All right, let's get into it. Get some practice writing those recurrence relations and developing them on your calculators. Good luck. See you next time.